Hello, my name is Tamara Jimenez Fernandez, and I'm going to present a study carried out in our research group, Cognition, Attention, and Learning Lab. Our study explores the inflexibility of the allocation of visual attention. When we want to find a target object, we look for it in the places where we know that they usually can be found. That is, the probable location of a stimulus biases where we pay attention to. For example, we know where to look for direction signs, street names, or buttons to close the computer programs. One of the most popular paradigms that has been used to experimentally study this attentional bias is the probabilistic queuing paradigm. In the most common version of this task, participants have to find a rotated T presented among several distractors and indicate pressing a key the orientation of the stem of the T. Unknown to participants, the T appears more frequently in one quadrant of the visual display, called the rich quadrant. As a consequence of this manipulation, attention is biased towards that location and response times are faster when the T appears in that quadrant. To explore the persistence or inflexibility of this bias, studies usually include two stages. In the bias stage, participants carry out the probabilistic queuing task as previously explained for several hundreds of trials. Without instruction or interruption, this stage is followed by an unbiased stage, where the target is evenly located across the different regions of the display. Despite this change in the spatial distribution of targets, participants usually remain faster when the target is located in the previously reached region. Based on this evidence, it has been suggested that this attentional bias is resistant to change. However, previous studies may simply have been underpowered to detect this decrease. We suspect that although the bias detected in those studies persisted over the unbiased stage, it probably decreases and may eventually disappear with a sufficiently long unbiased stage. We carried out a meta-analysis to explore whether the mean size of the probabilistic queuing decreases from the biased stage to the unbiased stage. We found meta-analytic evidence that the probabilistic queuing effect is reduced by about half in the unbiased stage compared to the biased stage. This result implies that the probabilistic queuing of visual search is not inflexible and can be better understood as a goal-driven attention phenomenon.